Oh my gosh, guys, I am such a liar. I am a liar. I was thinking to myself, I can just deal with this some other day. I'll come back to it. I knew I would not sleep tonight. I wouldn't sleep. I've got this compressor here. I know exactly what's wrong with it, and I know for a fact that I just need to fix this. I need to do this. So, the reed valve that's broken on this cylinder here, I know where I've seen that part here in my shop. I know it. And I was sitting there through dinner, and it just hit me. It hit me like a ton of bricks. I knew exactly where I was going to get the parts to fix this. All I have to do is clean it up, make it look nice and pretty. I got to get in and dress out some of these reed valves right here that have some rust in there. Geez, there's some debris up in there. So I got to clean that out a little bit. And to do so, I have this stuff called Super Slick, which is, it smells like an orange oil based type lubricant, which could be good, you know, because orange oil pretty much cleans away anything. But so I sprayed some down on this guy. There we go. I sprayed some down on these plates, and it looks like they're going to be good to go. So all you got to do is like clean off the metal flex. There's a lot of metal flex that are embedded up in there from that piston slamming the hell out of it. So I got to clean that off, make sure that this reed valve right here isn't damaged. It looks like it is. And I have a donor over here, and I'll show you where I can find parts. See, this is the one thing that I'm really good at, is finding parts in other equipment. When I was in the military, it's just one of those things I love to do, is when I was downrange and stuff, you know, we could find parts. Even though everybody said that something was down, I could still find stuff to get it up and going. And that is what I've done here. I know I have the parts to fix this guy, and I'm going to show that to you in just a moment. So that is the plate that's bad. Let's see. I'm using a dentist tool here to get down in there and clean away some of the garbage that's down inside it. We don't want any garbage inside our pump head, because anything that's in there will eventually migrate back into the path, and we'll be doing this all over again in the future. So I'm just cleaning away all that corrosion that's on the plate, making sure it's got a nice even mating surface. This is an aluminum plate, and some of those metal flecks are in there pretty good. So I don't know if I'm going to be able to get those out. I just got to make sure that there's no outliers. You know, any loose metal fragments can get in between the piston and the cylinder wall, and they will booger it up royally. So let's see. You guys ever have metal flex on something? Tilt that something at an angle and spray it down with like some other lubricant, and all those metal flecks just migrate right off the metal that's being machined. Now I do a lot of machining aluminum and stuff, and whenever I'm running taps or something, I always finish off at the very end blowing some oil down in there. Gets all those metal shavings out of the threads, and it cleans them up. So yeah, there we go. This guy. That looks pretty good. And I had a piece of, yeah, here it is. Got my O-rings. My O-rings are still intact. They look really good. I think I can compress them back down and get a tight seal. On the plate right here, I have my tweezers, because this right here is a piece of my old reed valve, and it just exploded. Ah, horrible. So you can see some of the corrosion that's down in there. Scrape it, clean it up, spray it out. I'm going to get this compressor running tonight. In just a couple minutes, I'll have it up and running. And I should have no problem reaching that 100 plus PSI. No problem at all. Let's see. Okay. So now that I'm here, I'm going to take off the old piece that had shattered. Wow. It's on there pretty good too. Probably got Loctite on it since it's a reciprocating piston. All right. So there's just this little strap that holds it down, and that is all that is remaining of my old reed. And there it goes. So I want to save that component, save the fastener, because I'm going to rebuild this in just a moment. Okay, the other one, I'm looking down in the gap to see if there's any debris stuck down there. It's looking really good. All I got to do is worry about some of these metal flecks that are embedded in the aluminum. There we go. Okay, that's as good as those plates need to be. Now let's see if I can show you guys inside of these pistons. So the cool thing about these is this all comes apart. See the cylinder sleeve, how it slides up? I have to get that off to get those other pieces out. Oh, there we go. And cool. Take a look at that. That was in between my seal and my piston body. The best place for it to be. If it's in between the seal and the cylinder wall, it would have scored the heck out of that, and it would have destroyed my cylinder. I can see one more over there. Anyway, I'm gonna have to take these guys apart to clean those out, because if any of this debris, yeah, see there's little pieces all up in there. If any of this debris makes it back into the cylinder, we'll be doing this all over again. That's not fun. Okay. Oh, no. No, 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 no. Ah. Well, score that idea. That guy is in there really, really good. Just getting a little bit of lube down there on the crankshaft. I'll pull the other one out as well. All right. Can never have enough shop rags floating around. So these are the cylinders. And I don't see any scoring. I see a little bit of debris. Oh, almost dropped it. That would have been bad. Okay. That's beautiful. So these are Weeble wobble pistons. And the reason I call them that is because all they do is they Weeble wobble in there. The piston head is hard fixed to the connecting rod. Sorry, I'm blanking out while I'm looking at this. Anyway, the connecting rod is hard affixed to the piston, whereas in a normal piston engine, your piston will actually rotate. It's got a wrist pin, and it will flop back and forth, you know, as the crank is going around. These do not have that. So what they have is an odd-shaped seal, and by it Weeble wobbling inside the cylinder, it maintains a seal, and it depends on its speed, because in order for these to make a good seal, they kind of have to go fast. Whereas, you know, normal engines can go kind of slow and still generate power. Wow. There's some stuff up in here. I really want to take this guy apart, but I don't think that's going to be an option. Yeah, I'm still pulling out little shards. Let me see if I can get it down closer. I don't think that's any better, is it? Anyway, you can see the tops of these pistons just littered with a bunch of stuff. So what I'm going to do is I'm going to wrap this piston with a rag to keep debris from going down in and around the crank. And I'm going to blast this guy with oil, and it's going to make these metal particles kind of float, and they will either blast out and all over my desktop, or they will float and they will kind of migrate onto my rag, and it's going to catch them. Look at that. I'm still pulling out shards. All right, so let's try it. Oh, yeah. So now I can just get in there with my pick, clean out the rest. Wow. Who would have thought that the reed would just explode like that? That's crazy. I don't think I've ever seen that before. Okay. I suppose when I'm picking and prodding at little particles of metal, I should probably be wearing safety glasses, eh? I'll just keep moving my desktop just in case. All right. Well, so far so good. Got a couple crusties down in there. Man, I really want to get those piston heads off. Let's see. Okay. There we go. Got to get out the impact. Let's see if I can get it off. I don't know, man. I hope those aren't reverse thread. I don't know why they would be. Neither one of those want to come out. Shoot. Okay. Guess you don't always win, huh? Flappers. You're right. They are flappers. Yeah, flappers, reed valve. They call them lots of things. They all are pretty much the same thing. It's just a piece of metal that includes a little hole, and that's what performs your valve functioning. Ooh, man. When the stainless steel valve exploded, parts went everywhere, man. This is just crazy. All right. I think I got most of them. I just got to make sure all the large ones are gone. Here we go. Okay. Okay. And I'm going to do the same to this one. Spray it down. Make sure it's really clean. Okay. Man, with the amount of little debris that's in here, and I'm missing more of my valve. There's no way that was all of it. So I wonder if it's sitting inside my compressed air tank or occluding one of my lines someplace. I don't know. I'll never know. But it's gonna run. It's gonna run. Okay. So that's looking clean. This one over here is looking clean. Couple more pieces. So you see all these shiny specks right here. That's where it actually came up and impacted, slammed up into the cylinder head. Which, let's see, is there anything up in there? Oh, it's looking good. Okay, let's go over these gaskets real quick. Okay, now let's take this guy, set him off to the side here because I got to bring up my donor unit and we're going to pull some reeds. The donor unit. Oh, you guys are going to love this. You probably wouldn't even imagine that this would have the exact same parts in it, would you? Ready for the big reveal? Ah, see? Here we go. So let's try it out. Let's see if they're the right size. They look like they're a little bit smaller, but I think they'll work. This is the same thing. You can see, there it goes. Just a Weeble wobble piston with the same type of umbrella seal on the side. It just Weeble wobbles up in the cylinder. That's all it does. Okay. Spare parts. I'll probably save this guy. All right, what do we got? Come on. Oh man, those look like a pretty good match. We want to be very delicate because that other side of it, I don't want to bend it or anything. There we go. In the bucket. Okay, so just got to make sure that the surfaces of these are super clean. There's a little bit of stuff on there. Right, there's one. I'm going to replace both of them. If you guys ever have some of these suction pumps or something that you're not getting really good suction, this is where it's at, man, on these little reed valves right here. there'll be little contaminants up there around the seal where it comes up to. All right, garbage. Here we go. So this one here might change that one out. Another thing you can do, like this valve is always bent out a little bit, so you can flip it over. And flipping it over bends it back towards the hole, and you might have a smoother surface on the flip side. On the flip side. See what the reverse side looks like. You can see it's a little dinged up right there. Wow. Whoa, it's a good thing I pulled that off. Look what I found. Okay, so there's a little bit of a size difference. I'll have to take a look and see if that's going to really matter. Okay. And look what's hiding under there. Another piece. Right there. Okay, that's looking solid. Now, since there was debris under it, I'm going to have to pull this cap right here off. I have to check that one too. Oh man, and these are rusted, really rusted, so I hope this doesn't booger it up. Here, might have to get some down force. Oh man. Needed some love, but I got it. Cool. There is some debris sitting around the valve seat. I don't know if you can see that. See that shiny section right there? So it's a good thing I pulled that apart. I almost did a half-assed job just to see it run again. I almost closed it back up. All right. That one's good. Now, if this valve seat was damaged a little bit, yeah, my dogs are snoring. See? So, if this valve seat was damaged, what I could probably do is throw it on the CNC and shave off 1/1000th of an inch. Maybe a little bit less than that. Just kiss it a little bit with an end mill and see if I could make that nice and flat again. But this one looks good. You guys are hearing my dogs. Stupid dogs. The worst part is they're not even sleeping. She's just snoring with her eyes open. It's actually kind of creepy. Okay. All right, this one's looking nice and clean. Excellent. Okay. Let's see. All right. I know this isn't that eventful, guys. It's just a slow and long process of making sure that this is done right. I do not want to half-ass this, get it back together, and it's only kicking out like 70 PSI or something like that, you know? If you're going to do it, might as well do it right. Right, and what I'm going to do on these little reeds, I'm going to preload it a little bit so that it wants to always sit down towards the valve. All right. So what I'm going to do is give it just a slight bend away from the valve seat, so it wants to always push it down. These are like spring steel, so you have to like give them a little bit of work in order for them to take a preload. There it goes. Like that. I think that's a win. All right, and that little piece I was saying in the last, it's just designed to keep that valve from close to its seated position. That's all it does. It's a very simple piece, but it has a very important role. All right. Come on. This is not so easy because it wants to rotate. And make sure it's all lined up nice and pretty before I tighten it down. There we go. Oh, it looks beautiful. So when you look at the gap, you see a gap right there. You just want to make sure it's not lifting away from the port. You want it sitting flush against the port, and that's why I do just a little slight curve to it to give it some preload. JJ says, "Hey Justin, did you see that Lewis Rossman video about right to repair?" Yes, I did. Yes, I did. Lewis is definitely putting himself out there this time. It's interesting. I'll give him that. I mean, you have your convictions, you stick to them. That's more power to him, man. Because there's some mighty powerful entities that are going to be standing up against him. Oh, look at that. That is going to work so beautifully. So that's going to be my replacement. Just like that. Yeah, Lewis, I sent Lewis some audio equipment a long time ago when we were tearing down an operating room. And he did a video thanking me for sending him some audio equipment, which is really cool. But yeah, I've been watching Lewis for years, man, years and years. Probably at least, geez, I've been here in Texas for 2 years, so that means I've been watching him for at least 4 or 5 years. Oh my gosh, that looks beautiful, guys. That's gonna be so awesome. Okay, so my O-ring looks fantastic. As long as it sits in its hole. Okay, so the O-ring is not going to cooperate. I'll have to worry about that later. Wow. Well, this is an older O-ring. There we go. That might be how I have to do it. I'll probably have to pack the O-ring while I'm seating it on the cylinder. Just go around the side really, really carefully with this and pack the O-ring around. That's going to be really complex. Anyway. Zoe, what you doing over there? Oh, and of course, I pay attention to the dogs and my O-ring pops out. I wish it could stay just like that. I've got wood scraps everywhere, and I don't have any the size that I really want. Oh, shit. All right, let's leave that guy right there. Okay, let's see. So this is the second cylinder. It's looking really clean. And this is a really well-made compressor. Like I said, I'm pretty sure that this compressor is going to be close to a couple $1,000s, if not more. All right. So since I pulled the other one off and I found some garbage under it, I might as well pull this guy off. It's really rusted, the fastener. That's why I'm putting this extra effort into it, because I don't want it to strip out. It's going to take very little for this guy to strip. Oh my gosh. I'm pretty sure all you guys see what just happened. Yeah. That's going to be fun. It was stuck on there really good. But you see it was corroded even after I scrubbed it off. All right, let's pull it off. Let's see what's going on. I don't know if that's lucky or not. I have enough of a nub there. I might be able to drill that guy and rethread it. The plate is actually kind of thick, so if I needed to, I could retap it and put another fastener in there, even maybe one slightly larger. This guy's gonna need some heat. I gotta get the torch out and I gotta show it some love, because that guy, hey, come to find out, underneath the valve seat, it's clean. You know what they say, you fix something good enough that it's eventually gonna break. That's what happened. All right, let's see. I need a vise. I wish I had a nice big vise here so I could put this plate in. I don't even think this is going to fit. Nope. All right, let's see what else I got. Okay. Torch it is. Okay, for this, I'm going to be using regular MAP gas. I almost have enough material to get on there with a set of vice grips. Oh, man. Just gotta be really careful not to score that valve seat, because if I do, it's game over. Why is it vice grips always have like uneven jaws? You see that? You would think brand name vice grips are where it's at, but they are not. Jeez. Nope. Nope, nope, nope. Okay. Next best thing. I'm going to drill it. It is what it is, man. So one of the things that I specialize in is metalwork, which is kind of unusual, you know, for Biomed, but believe it or not, this type of craft right here happens all the time. And because of that, it always helps to know metalwork. So one of the things I was first trying to do is I was first going to try and remove it using vice grips, but there's not very much there. And once I heat it up, this type of material is going to get even worse to try and grip onto. But she's got a dirty little secret. She has a recessed hole on the backside. That's really good for me, because other words, I'd have to grind it off flush on the front side. Because what you got to do is you have to put a start punch on it, and then you have a spot where your drill bit will center. So that's exactly what I'm going to do. I'm going to center punch it from the backside through the recessed hole. You see that? If you can reach the backside of a fastener, you're in luck. So I'm going to take a tiny little drill bit, and I have lots of drill bits, and I'm going to center punch it, drill it out, and go from there. Okay. All right. Well, I have an automatic center punch, but I think I'll try it. But that one's getting real close to the diameter of the hole. So when in doubt, I've got this guy right here, which has got a tungsten tip, and this is a scribe. So a scribe is what you use when you're working with a large material like this, and let's say I want to make a cut, you scribe your cut point, and that's how you can line up your holes, etc. So it's a scribe, that's what they call it. But I'm willing to sacrifice the scribe, which is only, you know, a couple bucks for one of those scribe pens, and I think it has extra points. Right? Yeah, I think there's extra points in it. So I'll sacrifice the scribe pen by using it as a center punch because I need a very precise center hole. All right. First, let's try it with this guy. And what I'm going to do is I'm going to be feeding this into the hole. And I'm going to try and get it as centered as possible. And you press down on this, and it has an anvil inside. And what happens is it's spring loaded. So as you push it down, it compresses until the anvil comes down and slams into it, and it creates a divot. And that divot is what you're going to use for doing your drilling. It's going to guide you. So this guy, let me get it nice and centered. There we go. And by the way, I built this whole CNC machine right here. All these plates and stuff that you see, like the bearing blocks are on, and the whole thing was done with this method, with a scribe, with a engineering square, and a center punch. The whole thing was, all the holes were lined up and everything using that technique. So you can do some pretty precise work this way. All right. All right. All right. I think I did it. So what I did is, in this little hole right here, I put a tiny, tiny little divot. I don't even know if the camera will pick it up because it's so tiny. You can kind of see it right there. So anyway, what I'm going to do is I'm going to take this tiny little hole, and I'm going to drill it through with a tiny drill bit. And there's some tricks. You know, people booger up drill bits so much. It's the most annoying thing. Half my drill bit kits, my indexes, have snapped small drill bits, like 3/16 and smaller, like 1/8. Why? Because people are horsing them and they're borrowing my drill bits, and there's nothing more annoying than that. So the trick is, especially if you have a drill press, even, steady pressure, slow speeds. With the harder the material, the slower the speed, and cutting oil. So all three things: speed, slow feed pressure, and cutting oil. And the trick is to cut through the fastener. And once I have a perfect hole through it, then I can thread a larger one and maybe a larger one after that. But what I can do is if I get one single hole in there, I can take one of these guys and feed it in there and maybe sacrifice one of these. This is a Torx bit. It's a little baby Torx bit, all right? And Torx is such a universal bit. You can use it for like metric Allens. If you have one that's kind of Weeble wobbling in there, you know, maybe it's a little stripped out, you can get a Torx bit that's one size larger, and you put it in the hole and you slam it with a hammer, and it basically cuts new corners in your stripped out Allen hole. All right. I could probably do that on that piston, but it's not really worth it. I got most of the debris off the piston. But if it was another medical device and I need to get a panel off or something, that's how I would do it, is you go to an Allen. You know, if ever you have a stripped out Allen hole, you can either drill it and just remove the head off the fastener and maybe do what I'm doing now later, or you can try and get the fastener out itself by using a Torx. And you just put a Torx up in there, slam it with a hammer, and then with nice and steady pressure. That's why I got these little tiny driver bits, because once the Allen's on there, you just use this guy to put steady pressure and back it out, and it usually works. All right, so I got my hole center punched. Now I have to find a drill bit. So let's take a look. I have lots of drill bits because you never know when this is going to happen. So I got all sorts of indexes. Okay. Okay. So this is perfect opportunity, guys. So I have 3 different bits here. So I have here high-speed steel, which is a general drill bit. Sometimes they can be very cheap. Okay. I have here a black oxide or boron oxide coated. These ones tend to be more fragile, but they're a harder material. So the harder the material, the more it wants to fragment. All right. So you have to know what you're doing in very slow pressure when you're drilling through things like stainless steels. You have to step it up. And one of the other popular ones, this one right here, you should know it by its color. So these are titanium oxide coated. So it's high-speed steel, and it's got that yellow color because it is titanium oxide coated. Now that coating supposedly makes the drill bit a little bit harder, but at the same time, it adds some lubricity to the drill bit. So this is just a Harbor Freight one. Because this fastener snapped off the way it did, and I'm looking at the inside of it, I can tell it's kind of a softer metal. I have no problem using these. Remember, slow speeds because it's a harder material, slow feed rates, and cutting oil. So let's see how this works out. Okay. Oh. Guys, that is the problem with using a large chuck drill. Now, it's beautiful if you have large work to do, but when you're this kind of diameter, this is what, 1/16. 1/16, the chuck does not want to grab it snugly enough. Yeah, there's got to be some pressure on this guy. So I've got to step it up. And that's the next thing. I thought I had the perfect drill bit. Not so much. So now I have to step up the diameter, and hopefully the chuck will grab onto it. There we go. Okay. Today, my lucky day, guys. I'm gonna step it up a little bit larger. All we can do, man. That is a loud ass dog. You're right. Hey, hey, what you doing? You're right. Okay, well, I found one that's gonna work. I guess the good thing about using a larger size drill bit is you don't have to worry so much about it snapping. But now my tolerances between the drill bit and the sidewalls of the fastener hole, they're getting kind of close. So I got to make sure that it's nice and centered. So that's the importance of a center punch, because if you don't have a center punch and you try drilling, it's going to walk, usually in an elliptical pattern because it's spinning. And I got my drill speed the slowest it can go. For me, which means so I want 280, so A4. Okay. All right. All right. Oh, man. This drill bit is slightly bent. As soon as I could just see a little bit of wobble, and you do not want to have a little bit of wobble. You can check that by laying it on the table and seeing it if it's flat or if it's got a little bit of a lift. Okay. All right, guys, that couldn't have gone better if I wanted it. All right. You can see what happened to the fastener. I drilled all the way through it. You see that? It's a little tiny piece of the cap that just kind of gave up because I removed so much material. So now the best thing would be is to go from the back side and re-tap it. And I got to see if I got those taps. Hell, I got to see if I got that fastener. I have that entire blue bin over there full of fasteners because you never know, something like this can happen. All right, so I took the head off it, and I have almost a perfect hole. And the sides are shiny. They're shiny because that's the fastener, right? So I drilled right through the middle of the fastener, and I have black threads, and then it starts getting shiny. That's the remnants of the fastener. So sometimes what I can do is take a pick and just pick at the sides, and you'll get your fastener just to coil out. It does happen. So this is really close. Man. Maybe I'll see if I can get it with a Torx, like I told you guys. Because once you relieve all the stress from like most of the fastener in the hole, then what you can do is you can take something like a Torx, beat it down in there, and kind of back it out. You'll get like a coil of threads. So let's see. I mean, it's already broke, right? Sorry. I hope you guys aren't epileptic. You'd be going nuts right about now, huh? Okay. These are cut-resistant gloves, by the way. If you guys were wondering what the hell I was wearing, I know gloves on a rotary is normally very, very taboo. But I was working with something tiny; it wasn't going to spin or anything. So these are more so to keep the metal flex, the little tiny pieces of whatever, from getting in your hands. Because I have had more than my share of metal in my fingers. You know, I've had a lot of metal in my hands throughout my history. So. Let's see, where am I going? This guy. All right. Well, this is my little tiny kit from Weeble. And what's really cool is it's got all these different sizes. You can practice with different sizes to see if I can get the outside of that fastener to come out. Okay, so this one, since Torx are tapered a little bit, you can just find one that barely slides in the hole, and it usually kind of grabs, like this one. So let's see what we can do. Ooh. There we go. See, I'm flat spacing stuff, guys. All right, so the trick is to put it on there, put it in reverse. Okay. And then we tap it while giving it slight pressure. I'm going to go up a size. Man, I'm almost thinking I should just tap it. All right, hold on. All right. Excellent. All right. Let's see. I think for this one, instead of just guessing, let me find a fastener that will replace it, and then I'll thread the hole for whatever fastener I can find. Oh, wait a minute. I just had fasteners. On the donor pump. Okay. Those are coarse thread. That's not going to work. Okay. Go. All right. So what I had to spend some time and find was a good stainless steel fastener because they're going to be high. They're going to be harder. Hey, Bjorn. Okay. So now that I have this guy, now I can find the tap for it, and it looks like I'm going to have it. Let's see. SAE. So if you guys have never done this before, since I'm going to be putting a new fastener in the hole, I can change it to whatever thread I want since it's going to be close to the same diameter. So I'm not really concerned about what was in there. Now what we have to do is we take the fastener and we have to match it up to your thread gauge, right? It's this little comb, right? It's got all these different combs on there. There we go. So we match it up and we find the thread pitch, and then that will tell us the tap that I'm going to use. Oh, this is a little guy. I bet you it's metric. Over here in the States, for all you guys that aren't from the States, it's such a pain in the ass because we have metric, we have standard. When we get into medical equipment, there's a lot of stuff that's metric. I mean, if we're gonna do metric, let's do metric. Hell yeah, let's do it. But it's this flip-flop in between. This just confuses the hell out of us. Plus, I got to keep 2 tap and die sets. I got to keep 2 helicoil kits, 2 of everything, you know? Let's just go metric. Who cares? Let's do it. Let's try this. All right. Okay, that's close. So it looks like 0.75. Nope. 0.7. Okay. So that's what you do is you match up the comb to the thread, and now I know it's a 0.7. Now I find the tap that's going to be as close to that as possible. And right here, I got M4 by 0.7. Let's see this one. Yeah, that's it. And the correct thing would be to look up the correct drill and drill it to the correct size. But I ain't going to do that, all right? I am not going to go through all that hassle. I am just going to run this tap from the back side and hopefully, you know, back out the fastener on the front side. Oh yeah. Okay. Good enough for government work. Let's give her a shot. And I don't have the proper tap handle to do this. I don't know why. This should have been done a long time ago. You know, if I wouldn't have got a little zealous and pulled that last piece off, I'd be absolutely fine right now. But we're this close. I guess I'm just gonna have to. I'll run it with a drill. I know some people are probably screaming, "No, don't do that! You're gonna snap a tap." Let's see if I can booger up a tap. Nice and easy. Well, it's ready. All right. Risky business here, guys. So when you're working with this small of a diameter of a tap, you have to be extremely careful. And I am at a very careful point. I ran the tap down until it hit the old fastener, which is hard material. And this is where people snap taps, okay? Gia Steve, that is exactly what I'm gonna do. I'm gonna put this in the drill press, and you manually crank the drill press by hand while you're pulling down on it a little bit to give it a little bit of pressure. That way there, if you feel it bind, you have some tactile response and you won't snap this up, because I would much rather snap a fastener than a tap. I do have ways of getting tap out of aluminum, but it just takes forever and it's such a pain in the ass. So this guy here, I think I need to run it one size larger on the drill bit though, because yeah, I think I do. Okay, let's do it. That is not the next drill bit. Let's see. All right, I'm taking it up two sizes. I thought that was a little weird. All right, one size at a time, right? Okay. Nice. All right. That is what I'm talking about, guys. So I took it up one size on the drill bit, and it de-threaded the coil. So you can kind of see, man, this camera just fucking sucks. It de-threaded the coil, and I can see the Loctite that was sitting in there. And of course they're going to use Loctite because you don't want the stupid thing buggering off while you're running a reciprocating piston, because it'll beat the piss out of it, right? So let's get the rest of the metal flex out of there. Now, I think I'll just do it Gia Steve said, and I will finish threading this guy in with the drill press, nice and easy like. And I'm going to throw this fastener in there, and I should be good. Let's see. I think we'll be all right. I was just wondering about the length of this fastener. I do have a grinding wheel here, so if it sticks through too much into the cylinder, then what I'm going to end up doing is taking this to the grinding wheel and just shaving off the very end. I think it'll be all right, though. Okay, let's tap this guy. Okay. Great. All right, guys. Well, guess what? Luck might be on my side after all. So not only did I get through, and there was some tiny debris. Some of you guys are going, oh my God. Yep, it did happen. My taper just fell apart. It just came right off on the Moore's taper and right into my hand. Timing's everything. You know, if I was doing that while I was drilling it, it would have probably boogered up this plate for sure. But I guess it works, right? So there it is. There's a tiny little bit of debris on the tip. Just a little bit that was in the threads. It's good to go. So now I got to get the tap out of this in order to oh, by the way, I'm doing stuff without even telling you guys what I'm doing. I got to get the tap back out, right? Don't back a tap back out if you have access to the back of it without cleaning off the garbage on the back, because what you're going to do is you're going to drag that crap back into the threads, and it's going to bind. All right. So if you have a tap that is through a material, get some oil and spray it down and get those chips off it. Because if you back that bit back through the material, you're going to drag those chips back in, and it's going to gall, and it's going to destroy all that hard work you just put into it. All right, here we go. All right. Now I got to clean my taper off because I need to put back on there. Some of you guys are going to be like, no, don't do it. I'm going to do it. Okay. Let me get my gloves again. A little bit. All right, so I know some of you guys are gonna be like, no, don't freaking do it. I'm gonna do it, guys. I'm gonna heat this guy up just a little bit, and I'm gonna fit it on the Moore's taper, and then it's gonna be nice and solid. All right. I'm not gonna change this chuck. It's on there, and if I need to get it off, I'll just heat the stupid thing back up and get it off. I don't even care. Just a little bit, just to heat it up, just enough to make the metal expand. Put it back on the Moore's taper, and then you pull down on the feed of the quill, and it will really cinch it on there good, nice and tight. There we go. All right, so the friction clamping force of the steel on steel with the Morse taper is going to be plenty. I don't have to worry about that chuck coming back off anytime soon. There's a little bit of oil, from all this cutting that I've been doing. You heat up the chuck and, expansion and contraction. You get oil on that Morse taper, and eventually it just slips out. It just happens. So that's what I did. I just heated it up, cleaned it off, heated it up, and then pressed it on. And now once the metal, you got cold metal plus a hot metal, the hot will cool down rapidly and cinches down on the other piece. Anyway, here we go. God, jeez, look at this. Here we are. What, 30 minutes later? And my dog is like not giving up, is she? Hey. Hey. Why don't you go outside? Come on. Come on. You're being like so loud. Come on. Come on. Come on. Come on. Yeah. Come on. Come on. Big stupid. All right. Well, I got the loud dog gone. All right, guys. So we got the hole. I got my fastener. All I gotta do is clean it up a little bit. Put some Loctite on there. And we're good. Actually, it looks kind of clean. Okay. That's going to work, guys. That is going to work. Okay. Next. Let's see. We got this one. Let's see. Where is this? Okay. Well, I'm just looking to make sure everything's clean and flush. Now I'm ready to put it back together. Take a look at the old reed. So the old reed's got some divots. It's got some imperfections in it. That's why I need multiple cameras, guys. Multiple cameras. Okay, you can see right there, see some of the divots. Imperfections. Those imperfections are going to cost you PSI. So I have this one here. My valve seat's nice and clean. Okay. Again, I'm going to give it a little bit of preload. Make sure it sits nice on that hole. You're right, Bjorn. You are absolutely right, man. I think I have some of that strapping. I mean, I have feeler gauges. You know, if I really need to. Some people still have those. Wow. All right. I just noticed that there's rust and corrosion in this cap, so I got to clean that out too. I'm going to use the tap to help clean that out. There we go. Cool. I think it's about ready to go back together. Okay. Looks really good. All right, I'm going to back it back out. I'm going to put some Loctite on this bad boy because the threads could be in all sorts of condition. Okay. Because the temperature of the head as it compresses air, it's going to get hotter. I'm using Loctite Red, and this stuff is thermally capable of handling like well into 100 degrees C. So we should be good. Should be, right? Famous last words. Here we go. Little dabble, do you? Somebody's probably thinking, oh my gosh, that's way too much Loctite. Never too much Loctite. As long as you're not expecting to pull it apart again. Okay. Actually, it's too much Loctite. I got it on my reed valve. All right. Okay. All right. What? You guys thought I was done when I snapped that fastener off, huh? No, sir. Okay. Looks pretty good. I'm just making sure that the reed is staying nice and square to the opening, and it is. Okay, cool. Next, now for the valve that exploded, this one right here. And for that, I'm going to use my other one, this little guy. Shoot, if I can get it off the table. You want to talk about a perfect fit? That fastener I found is almost flush. You see that? Almost flush. That's beautiful. There we go. It's going to work. Okay, what do we got? What do we got? I need to clean off my workspace, guys. I got too much stuff going on. I'm not drilling anymore. Put all this stuff back. This guy. Okay. You guys ever wonder how these things booger off? Flat surfacing, just like that. I have a magnet on my drill press that holds my key, and I just have to remember to put it back. Just put it back. Okay. So see, we got this guy, we got my cylinder sleeves, my O-ring, my cylinder risers. Just put all this stuff back because I'm going to bring the compressor up here and we are going to slap this bad boy together. Okay. So these, I got so many extra tools up here and a lot of them didn't even help me out. Drill bits. Boy, always remember to put your stuff back in your tap and die set. There's nothing more irritating than finding missing stuff in your tap and die set. Okay, let's see. So I'm looking for one little piece that I took off. This guy right here. Okay. So shoot, guys, I was going to spend this afternoon redoing my my Milwaukee pack out drawers, but I just knew I wouldn't sleep tonight knowing that I had the parts to finish this guy up. All right, so a little bit of Loctite on that guy. All right. Ooh. Wow. Hell yeah. Nice and flat mount against the porthole. That looks pretty good. Pretty darn good. Let me line it up just a little bit better. There we go. My snoring dog tried getting back in the garage. Okay, so this guy's ready. The Loctite away. Let's collect all the tools. See, this is where I need a service cart so I can just throw my tools on the service cart and press on. this and that. Old breed, garbage. Don't save old parts. All right, let's move this garbage over. Let's get him back up here and let's finish this job. All right, big. And let's move you back up here. There we go. Okay, so let's see. I got my cylinder heads. Let me make sure that they're still clean. Nothing fell in there. Good. Good. No burrs. All right, we're ready to start rebuilding it. So what I'm going to do is I'm going to get a light, thin coat of grease, and I'm going to put a tiny little bit of grease on the inside of these cylinder walls, just a tiny bit, to make those dry seals glide in a little bit easier. There we go. Put just a tiny amount on there. Oh my gosh. These are special. Oh my gosh, you guys probably know exactly what I'm doing wrong, don't you? Here I was thinking that it was just going to slide right back on like the other Weeble wobble piston. But these umbrella seals here are a little more particular. I got to be really careful. And I got to show them just enough love to make it go back over. Right, there we go. Oop. Come on, get back on there. Okay. That's looking really good. All right, now time to do the other one. So I'm trying not to catch the edge of that seal as I'm putting the sleeve back on. Very difficult. There's not very much room for mess ups right there. Okay, let's try this one. Okay. All right, that should be good. Put the second one back on. I just start at one side and I press the seal all the way around so that it doesn't bind. Nice and easy, just like that. All right. Whew. I was thinking that umbrella seal was going to be too open for me to get that back on. I was sweating it. Guys. Okay, we got that. Get these guys. Right. Got that. Oh boy. These seals are not going to be easy. Oh, this sucks. Oh, this is going to suck. All right, so you can see the gasket wants to pop out. I have to compress it down, which is fine. It's fine. But it also has to match up to the cylinder. Oh, and that is never going to work out in my favor. Okay. Guess I just got to be quick about it, eh? Jeez. Something like that. Come on. All right, so I just got to make sure that that is all the way in. I'm not pinching the seal, which I am on this side. Okay. Oh, man. Okay. All right, there's one. Jeez. That is not easy, guys. And now, how do I keep that there? How do I keep that there? Did I do it? Just got to check and make sure that that seal is all the way around. In other words, this is all useless. Okay. That's one. Oh, jeez. This is not easy. Oh, this is enough to frustrate the hell out of you. Repacking gaskets. Okay. Let's do it. Let me do this. Okay. This is going to be in my way. I just wanted to stay out of my way for a moment. Okay, there we go. I just need to get my fingers in there to hold that plate down. All right. Guys, this is crazy stressful. This stupid seal. Okay. You stupid thing. Oh, this so sucks, guys. Oh, okay. I need this piece to be out of my way. I need this to come off. And how do I do that? Without bumping that one. Okay, turn it. Yep. Nope. Okay. My knuckles cracked. Did you guys hear that? My knuckles cracked. Oh my gosh. You know, Bjorn, I might have to resort to the super glue. I'm hoping all I gotta do is get this the hell out of my way. This whole thing is just enough to upset me. Okay. So what I need to happen is I need this guy to fit on just like that without coming off. The other mechanics trick from way back is to use some thick grease. And you apply some thick grease into the groove, and that will retain your seal. And yeah, I could do that. I just don't want to use any petroleum products next to, you know, a compressor that it's going to get hot. Oh, come on. This stupid thing. Come on. Oh, if you guys only could see the frustration. I'm trying to keep my cool because I'm on camera, guys. I might not normally be so cool about this. All right. All right, I almost got it. Oh, come on. Get up in here. Oh, you dirty girl. I got you. All right, come on. Okay, let me check it to make sure it's all the way around. And it is. Now, as soon as I put that other piece in here, it's going to want to booger off. I already know. Right. Nice and easy. Oh, I might get lucky here, guys. The easy thing would be to just put silicone up in there. Get some thick ass silicone and put it up in there and just say it's good. All right. So here's this piece. I'm going to prep my head bolts here so that this is ready to go as soon as I get it lined up, because I don't have a chance to find my tools once it's lined up. That's it. It's make or break. All right. Here we go. Let's see, there's one head bolt. Let's see, there's 2, 3, 4. If I get 4 head bolts in, you know, diagonal on each cylinder, I think it's going to be all right. Let's do one last check. Okay. Okay. Oh, guys, I think it's going to work. Nice and easy. So nothing touches nothing. All right, my cylinder heads. Do not bump. Woo! Straight downward pressure. 1, 2. Come on. Where are you? 3, 4. Okay, there's that one. All right, so I'm just going to barely put pressure, downward pressure on the 4 corners, and then I'm going to recheck that seal because I can still push it back up in the spot if I need to. Just enough, not enough where it's creasing my O-ring, just enough. Okay, I think it's going to be all right from here on out. Okay, there we go. All right, let's see. Woo, that's looking good. You just poke at it, make sure it's not popping out. Oh, that's looking excellent. Okay. All right, it's go time, guys. It is go time. Uh-oh, my bit's not letting go. All right, so here you can see I'm resorting to hand tools again because I want to feel if there's a problem. I don't want to hit it with an impact. That will certainly fuck something up. All right. Okay, I got them most of the way down, so now I can start putting in the other head bolts. That's the 4th or 5th time this little weehaw has reversed direction on me accidentally. There's some slop in this mechanism right here, and I am not liking it. Not liking it. This weehaw used to be really good, but as I've used it for more and more stuff, it's starting to develop some slop in the reversing mechanism, and I'm starting to get upset. Okay, so my heads are down. They're not tightened down, they're not torqued down or anything, but they're down and the O-rings are in place, so the worst is over, guys. Let me tell you. I mean, technically, if I wanted to try it out, I could probably even try it out. Man, I don't even know what time it is, guys. I'm dropping stuff. Just everything's all goofy right now for me. Woo! All right, come on. One more and then I torque them down. We're good. You guys know that old adage where like your last fastener will always mess you up? That's this one. There we go. It just didn't want to start. It was off by just a little bit. Okay, that one's torqued. All right, that one's torqued. That one's good. Okay, that one's good. Ooh, guys, can you feel it? I'm getting close. Is that one? There we go. All right. Yes. Whew. Okay, let's connect the hose that I disconnected. All right. Yes. You guys ready to do this? Y'all have been sitting there. People have been coming and going from the feed. And okay. Here is where the cylinder heads explode. Ah. Now I have heat building up in both of these. Look at the pressure, guys. Look at the pressure. Ta-da! It reached its cutoff point, and we are good to go. What is the cutoff point on this guy? 125 psi. What? Okay, let's drain it out. Let's test it out again. Yes. ship it. All right, guys. That's what I'm talking about. This, man, this compressor is almost like brand new. I'm going to pop it again. Watch your ears. That dual stage compressor. Nice. Both of them are nice and warm now. That is what you want to see. Oh, that's so perfect. And I don't hear any leaks. All right. So that means that this last valve is good. Yeah, both cylinder heads are now getting hot, which is exactly what you want to see. Oh my gosh, guys. How stressful is that? Snapped a fastener off, had to retap it. What a lesson. I'm glad that you guys were here with me because nobody would believe me. So it technically was an easy repair. I should, if I had compressed air, right? I would have just blasted out those reed valves instead of taking them apart. As soon as I seen the rusted fastener, I shouldn't have pulled it apart. Why did I do that? Well, I just wanted to be sure just in case. And, you know, there we are. So I will never make that mistake again. I'll just blast it out next time, maybe with some oil and some compressed air. And this guy is good to go. I'm going to blast it down real quick. I deserve that. Ah, best blowjob ever. There we go, guys. Time to ship it. Anyway, that's another reason for me to have this this kit right here, is because all I got to do if I have equipment like this throw it on my pack out and go. Get back to the shop. Guys, I'm glad that's over. And look, at 10 o'clock, perfect timing, right? Anyway, I'm going to let y'all go. Thank you if you stayed tuned that entire time. I am absolutely amazed if you guys did, because that was quite the production, wasn't it? Like going from into a compressor troubleshooting to, you know, scavenging parts to metalwork, drilling out an old fastener, retapping, and reassembly. Every single step of the way, man. You guys seen it, and here we are. I'm gonna give it back to him tomorrow and tell me don't call me again. But anyway, this is the one that my boss told me do not touch. He said it's their problem, and I brought it home. Because you never know what you're going to see. I mean, obviously, I'll tell you what, if I run into this problem on this guy, I guarantee some of you guys are going to see that exact same problem. And now you know that you can scavenge parts from an old suction pump if you need to, or you can make your own reed valves, which is what I did. I've done it before with feeler gauges. I mean, it is what it is, right? So anyway, guys, I'm going to let y'all go. I'm going to throw some tools in my pack out because I'm going to take some of my tools back to work, you know, like my Torx drivers and stuff. I just miss that, you know, when you need it, you need it. So thank you all very much for this. I hope you guys enjoyed this. I hope you learned something. I know I learned something. I will never pull apart a rusty fastener that's really in there. So guys, I'll see y'all next time. All right.